So in this video, we'll go through the rules of naming ketones. So recall, ketones are also carbonyl containing groups. So they contain a carbon-oxygen double bond, which is your carbonyl group. However, they contain carbon atoms directly attached to the carbon of the carbonyl. Those carbon groups that are attached to the carbon of the carbonyl could be the same or they could be different. But you can identify the ketone by the carbon of the carbonyl having two carbon atoms directly bonded to it. So if we go through the rules, the first step is still to identify the parent chain. Just as with other carbonyl containing molecules, you want the longest continuous chain of carbon atoms that includes the carbon of the carbonyl group. And so, since the carbonyl group is located closer to the right side of the molecule, I may just start numbering or counting from that direction. So 1, 2, 3, 4, 5, 6, 7 if I go straight across. 1, 2, 3, 4, 5, 6, 7 if I go down. 1, 2, 3, 4, 5, 6, 7 if I go up. So with this particular molecule, if I go straight across, for those 7, I have 2 substituents present. However, if I didn't go that direction, so let's say I decided to go down instead. So 1, 2, 3, 4, 5, 6, 7. If I had gone like this instead, I would only have 1 substituent. Whenever you can get your parent chain multiple ways, you always want to go with the direction that will give you more substituents. And so because this way at the bottom only gave me 1 substituent, I wouldn't use that method. So I wouldn't want to go down in order to determine my parent chain. Right now, it looks like I would want to go across. I'll do the same process with going up instead. If I had gone up instead and boxed off those 7 carbon atoms, so 1, 2, 3, 4, 5, 6, 7, it still gives me 2 substituents. The top 2 that I'm showing are basically identical. And so I'm just going to use the top structure that I have drawn. I just wanted to show that so that you will know that it does matter how you identify your parent chain. You always want to go with the longest continuous chain of carbon atoms, but if you get that tie and one gives you more substituents than the other, then you want to go with the direction that gives you more substituents. So it's like it's giving more details about how to name that compound. So let's go back to our rules. We have our parent chain identified. We've determined that we have 1, 2, 3, 4, 5, 6, 7 carbon atoms. So we would normally call that heptane to represent those 7 carbon atoms. But as we've seen with other molecules that contain functional groups, we have to change that ending. So we drop that E, and because we are naming a ketone, we'll replace the E with O-N-E. From there, we have to identify substituents. So I have this branch here, and I have the branch up top. The branch up top, that's 1 substituent that contains only 1 carbon atom, so it represents a methyl. The branch on the bottom, it's 1 substituent because it's 1 bond coming from your parent chain, but that 1 bond leads to 2 carbon atoms, which represents an ethyl. So we have our 2 substituents. We have to indicate where everything is located. So we need to number that parent chain. You want to number your parent chain to give your functional group the lowest number possible. Even if it causes your substituents to have the higher number, you want your functional group to have a lower number. Because my ketone functional group is closer to the right side of that molecule, that's a clue that you want to start numbering from right to left. So since I said there were 7 carbon atoms in my parent chain, I'm simply numbering from 1 to 7. Doing so indicates that my functional group is on carbon 2, my ethyl is on carbon 5, and my methyl is on carbon 6. So I've identified my parent chain, I've identified substituents, I've indicated where everything was located. Now I can put the name together. When you put the name of this molecule together, you have to list your substituents first. Because I have different substituents, I have multiple, and they're not the same, I have to list them in alphabetical order. I also have to include where they're located. So I have to compare the E for ethyl to the M for methyl. So of course E comes first. And so since the ethyl was located on carbon 5, I have to make sure I keep that number with that substituent. So the name of this molecule 5-ethyl, because that's where my ethyl was located. My methyl was located on carbon 6, but I also have to indicate where my functional group is located. The functional group is not an actual substituent, but it's treated as a substituent because we have to indicate where it's located. Based on the number in my parent chain, it was determined that my functional group was located on carbon 2 of my parent chain, which contained a total of 7 carbon atoms, to give us the name of 5-ethyl, 6-methyl, 2-heptanone. That name tells you the atoms that are present. It also indicates how they are bonded. It indicates that we have a ketone that is attached to a chain of carbon atoms that has 7 continuous carbon atoms, but that ketone functional group is branching from carbon 2 or attached at carbon 2. There's also a methyl attached to my parent chain branching from carbon 6 and an ethyl branching from carbon 5. So that name tells you pretty much all you need to know about the molecule. So what if you were asked to draw the structure of a ketone? So let's say you were given the name 3-methyl 4, I'm going to say decanone. Again, the name tells you about that molecule. In this case, because of how it ends, so that suffix lets us know we have a ketone. So the suffix of organic compounds tells you about the class or the type of compound that it represents. The dec lets us know we have 10 carbon atoms. This 4 tells us exactly where our ketone functional group is bonded on my parent chain or on this continuous chain of carbon atoms. Then I also have a methyl, which contains 1 carbon atom that is branching from carbon 3. So it tells me all that I need to know about this structure. From there, I can simply draw it. As soon as I put this marker down, I'm on carbon number 1. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right now I have decane. In order to make it decanone, I need my ketone functional group. Based on the name, the ketone functional group is on carbon 4. So I can choose to number from left to right or right to left. I just have to make sure that I remain consistent. So if I go from left to right, this is carbon 1, 2, 3, 4 is where I would have my functional group. So that's where I would draw my carbonyl. This represents the ketone because that carbon is directly bonded to 2 carbon groups. So right now I have 4 decanone. But I have to add my substituent. I have a methyl group branching from carbon 3. So I can't switch and now jump over here and say this is carbon 1. You have to keep counting in the same direction. Since this was my carbon number 1, counting over 1, 2, 3 is where my methyl group would be located to give the structure of 3-methyl 4-decanone. I'm going to erase that 1 just so that no one's confused and thinks that it's part of that structure. So here you have the completed structure of the 3-methyl 4-decanone.